Hello everyone, this is Pratiksha, and today we're going to be talking about cosmology. So, everybody would have heard about cosmology, right? Um, it seems like a very fancy word. So, today we'll be learning about what is cosmology and the parts in it. So, what is cosmology? Cosmology is a branch of metaphysics that deals with the nature of the universe, or it is a branch of astronomy that deals with the origin, structure, and space time relationships of the universe. The universe is everything, from the tiniest particles to the largest galaxies to the very existence of space, time, and life. But how did it all begin? The origin of universe is the origin of everything. The most widely accepted explanation of origin of universe is the Big Bang theory. The Big Bang theory states that the universe began as a hot and infinitely dense point only a few millimeters wide, and so it was similar to a supercharged black hole. And about 13.7 billion years ago, this tiny singularity violently exploded, which led to the creation of all matter, energy, space, and time. And from this explosion, this bang, all the matter, energy, space, and time were created. After that, it was the evolution of universe. And evolution of universe had two major stages called the radiation and the matter eras. They are defined by the key or main events that helped shape the universe. First came the radiation era, named for the dominance of radiation right after Big Bang. This era is made up of smaller stages called epochs that occurred within the universe's first tens of thousands years. The earliest or the first epoch is the Planck epoch. In this epoch, no matter existed in the universe, and at this time only energy and the four superforces of nature, which are gravity, strong nuclear, weak nuclear, and the electromagnetic, were present. At the end of this stage, gravity split away from the four superforces. Then came the grand unification epoch, named for the three remaining unified forces of nature that are strong nuclear, weak nuclear, and the electromagnetic. This epoch ended when strong nuclear force broke away from the four superforces of nature. Then the inflationary epoch began, during which the universe rapidly expanded. Almost instantly, it grew from the size of an atom to the size of a grapefruit. The universe at this time was piping hot, and it churned with electrons, quarks, and other particles. Then came the electroweak epoch, when the last two forces, that are electromagnetic and weak, finally split off from the four superforces of nature. During the next stage, that is the quark epoch, all of the universe's ingredients were present. However, the universe was still too hot for the subatomic particles to form. Then, in the Hadron epoch, the universe cooled down enough for quarks to bind together and form protons and neutrons. In the lepton and nuclear epochs, the proton and neutrons underwent significant changes. They fused and created nuclei, and in doing so, they created the first chemical element in the universe, helium. The universe's new ability to form elements, the building blocks of matter, cured the matter era. The matter era is defined by the presence and predominance of matter in the universe. It features three epochs that span billions of years. The first was the atomic epoch. In this stage, the universe's temperature cooled down enough for electrons to attach to nuclei for the first time, called recombination. This process helped create universe's second element, hydrogen. This hydrogen, along with helium atoms, dotted the universe with atomic clouds. Within the clouds, small pockets of gas may have enough gravity to cause atoms to collect. These clusters of atoms formed during the galactic epoch became the seedlings of galaxies. Nestled inside those galaxies, stars began to form, and in doing so, they cued the latest and the current stage of universe's development, the stellar epoch. The formation of star then caused a tremendous ripple effect and helped shape the universe we know today. And heat within the stars caused the conversion of helium and hydrogen into almost all the remaining elements in the universe that we know today. So this was evolution of universe from its origin to the present day. Matter as we know it, atoms, stars, galaxies, planets, trees and everything around us accounts for less than 5% of the known universe. Then what about the rest of it? The rest of the universe comprises of 25% of dark matter and 75% of dark energy, both of which are invisible, and matter, as we know it, that takes up 5%. We really have no clue what dark matter and dark energy are or how they work, but we sure know that they exist. So, what is dark matter? Dark matter, it is the stuff that makes up possible for galaxies to exist. The gravity of visible matter is not strong enough to form galaxies or complex structures. As we know, the stars would be scattered all over the place and not form galaxies. Because the stars are always everything is in motion, the gravity we know it will not be enough to collect all the stars together and form galaxies. And so we know that there is something else inside and around them, something that doesn't emit or reflect the light, that helps them keep them binded and not scatter all of the place. So we can see dark matter kind of, not literally as in we can see kind of. Like places with high concentration of dark matter bend light passing nearby, as they don't emit or reflect light, so light doesn't go through or around them. So it bends light near that is passing nearby. So we know that there is something that interacts with gravity, and that is dark matter. Dark energy. What is dark energy? Dark energy is a hypothetical form of energy that exerts a negative and repulsive pressure, behaving like the opposite of gravity. Like dark matter, dark energy is directly not observed, but rather inferred from observations of gravitational interactions between astronomical objects. More is unknown than is known about dark energy. We know how much dark energy is there because we know how it affects the universe expansion. Other than that, it's a complete mystery. The first observational evidence for its existence came from the measurements of supernovas, which showed that the universe does not expand at a constant rate. Rather, the universe expansion is accelerating. One explanation for dark energy is that it is a property of space. Albert Einstein was the first person to realize that empty space is not nothing. Space has amazing properties, many of which are just beginning to be understood. The first property that Einstein discovered that it is possible for more space to come into existence. So Einstein basically said that it is possible for more space to come into existence as we move on with time. And more space is coming into existence as we speak right now. Then, one version of Einstein's gravity theory makes a second prediction that empty space possesses its own energy. That empty space which we are talking about that comes to existence or which already is present has its own energy. Because this energy is a property of space itself, that Einstein said that energy is a property of space itself, it will not be diluted as space expands. Because as space expands, people would think the energy which it has would be diluted, but it's not so because energy is a property of space itself. So as new space comes into existence, it brings new energy with it too. So it's a property of space and so it will not be diluted. So, as more of space comes into existence, more of this energy of space would appear. As a result, this form of energy would cause the universe to expand faster and faster. So, to understand this expansion of universe, we can take example of water particles. We can consider space as water particles dotted around and which have space between them, which also has energy with it. So at first the energy between these particles, water particles, will repel the water particles away from each other, which would create more space. So in that space, new water particles will emerge. That is, the new space is emerging, but it will bring new energy with it also. So that even the new water particles that are formed, that will also repel from each other, which will also again bring up new energy. So this process goes on continuing, and this process helps in the expansion of universe as new space and energy is coming out. In 1929, Edward Hubble examined how the wavelength of light emitted from distant galaxies shift towards the red end of the electromagnetic spectrum as it travels through the space. He found that fainter or more distant galaxies showed a large degree of redshift, closer galaxies not so much. Hubble determined that this was because the universe itself is expanding. Because as we talk, the universe is expanding. So as the light from the distant galaxies reach Earth, within that time the universe would have already expanded a bit. So it shows that the universe is expanding. So these are some pictures in which we can see whatever we have discussed. First is the expansion of universe. We can see the inflation where after the Big Bang, where the universe was just small as an atom, then it inflated, then the dark ages, then development of galaxies, and dark energy accelerated expansion. Because of dark energy, the universe is expanding. As we can see, it started from this, it goes like this, and it's going like this. And first, and the one more thing which I want to say is that at first people thought that as the universe is expanding, at a point of time it will expand, and because of the gravity in the present in the universe, it will collapse on itself and everything will be over. But after we got to know that the universe is constantly expanding, and it will not collapse on itself, but it will go on expanding, and that is because of dark energy which acts as a repulsion or opposite of gravity, that helps the universe to expand and not collapse on itself. This was found out after we got to know about dark energy. So in this picture also we can see the development of galaxies, the first stars which were formed, dark ages where nothing was there, and then the first stars formed, and then the development of galaxies, then the universe expansion, and which lasted for 13.7 billion years. The next picture you can see is of dark energy, how it's just a pictorial representation of dark energy, and the next one is also the evolution of universe. Then this picture also shows the farthest supernova, which we can use, which using which we came to know about dark energy, like how the universe is expanding. The farthest supernova would have been there, but as we measured at different times, the distance would be different. So this is how we got to know about the universe is accelerating in expansion. It also shows how the slowing in expansion and accelerating in expansion and the present time. And in the last picture, we can see dark matter, because we know that it doesn't emit or reflect light. We can see as the light bends over it, we can capture it. So that's it for today. We have talked about the origin of universe, evolution of universe, and what does the universe comprise of, including dark matter, dark energy, and all this was for today. So thank you.